Good afternoon, Agent LabRat. We just got word of nefarious behavior in the Ruddick House Library. It may be dangerous. Your mission, should you choose to accept it, is to navigate the villain's checkered lair and see what they're hiding on the other side. Good luck, Agent L.
Hi, this is our ME14 project. This is Stuart Middle, codename LabRat.
So Stuart Middle is a maze solving robot, as you saw in the video earlier. He is designed to solve a 2x4 square maze with various checkered tiles on the floor with walls around the sides. And basically he's trying to detect these different items to be able to progress further.
So the way he's able to detect all this is through a series of sensors working together. So the sensors that we have are 4 distance sensors on the top. They're ultrasonic and they point out from the robot, and so he's able to detect how far he is from various obstacles. And on the bottom there's a color sensing little thing here that senses the color of the tile that it's on.
So essentially the color sensor tells the robot when it has moved onto a new tile, and the distance sensors tells the robot where the walls are so it can map its surroundings.
Yeah, so in order to navigate the maze, that tile checking is a really important feature.
Yeah, so when he reaches a new tile, he's able to make a choice, and the choice is based off of the idea of progressing a maze by a left-hand solve. So in a traditional maze, as in there's none with just an island in the middle, you should be able to escape any maze by keeping your left hand on one wall and just going through. So the way that he mimics this process is that if the left turn is open, he will turn left. If that's not progressible, he'll go straight. If that's not progressible, he'll go right. And if none of those are options, he's at a dead end and he should turn around. And that is the way that he implements those.
Yeah, and at each of those key decision points that Elaine mentioned, that tile change is really, really important.
And so all these times we're assuming that he's going to go perfectly straight or make a perfect right-hand turn or perfect 180 turnaround, but that's, as we found out, is not the case. And so in order to compensate for that, we do different little adjustments while he's going forward. And so we use the ultrasonic sensors for that to see how far it is on both sides, and if it's too close on one side and too far on the other side, then he'll go towards the side that is too far from, to try to keep him as parallel with the walls and as middle of the walls as possible so we don't run into the walls.
A problem that we've been having with the robot is that its turns are sometimes overshooting or undershooting, so that it's not going straight or towards its desired direction. And the way that we can fix that is by calibrating the turn thetas or reducing the friction against the wheels and the actual robot itself.
Yeah, and that material for the maze is really important. So our maze is made with an MDF piece on the bottom and colored paper on the top. And keeping the material consistent allows us to calibrate the turning beforehand. That way, when it encounters a new material, we won't overshoot.
Yeah, so that's our ME14 project in a nutshell. But yeah.
Yeah, I hope you enjoyed this video. We had a lot of fun making it.